All right, let's look at something called implicit differentiation. And this is going to be a kind of a different thing because we've always taken the derivative primarily with respect to x. And so we're going to look at, well, what if you're taking the derivative with respect to a different variable? So let's look at this chart. It says find the derivative of this function with respect to x. So if I say, what's the derivative of x with respect to x? Well, you say, well, that's what we've been doing. I'd say it's 1. What is the derivative of 3x with respect to x? And you'd say 3. What's the derivative of x squared? 2x. So that's the derivatives that we have done. But wait a minute. What if you're taking the derivative of t squared with respect to x? And what happens is it becomes a chain rule issue. So if I take the derivative of t squared with respect to t, let's go down here and do this one actually. If I say, what's the derivative of t squared with respect to t, you'd say, well, that's 2t. But if I say, what's the derivative of t squared with respect to x, you would still have the 2t, very small to write in here, but you would have to also take the derivative of t with respect to x. You have an inner derivative, so you'd have dt dx. And so if I said, what's the derivative of y with respect to x? You would say, well, you would take the derivative of y with respect to y, which would be 1, but then you'd have to take the derivative of y with respect to x, so you have 1 dy dx. So you try the last two there. What do you think the derivative of 5y would be with respect to x? You take the derivative with respect to y, and then you have a chain rule issue where you have dy dx. You have 2y, and then you have dy dx. And then later in the unit, we'll actually be taking the derivative with respect to t, because t is going to be like time. And so what you have to remember there is if you're taking the derivative with respect to t, if you're taking the derivative of x, you would get 1, and obviously you don't have to write the 1 like I did over here with this one. So what's the derivative of x with respect to t would be dx dt. The derivative of 3x with respect to t, you take the derivative with respect to x, and then you have a chain rule, dx dt. 2x dx dt. If I was doing the y's, it would be dy dt. 5 dy dt. And then 2y dy dt. So in this unit, you're not always going to be taking the derivative of with respect to x, so you have to be careful with that. So when I say the word implicit, what does that mean? Well, explicit means the equation is solved explicitly for one of the variables. So if I wanted dy dx, you would just go, okay, dy dx, derivative of that, and it would be 6x, and you would be done. Well, this is the type of equation where you go, well, golly, that one is not solved for y, and it would be really hard to do that. If they ask me for dy dx of that equation, you're kind of stuck. You don't know how to do that, and that's precisely when you do implicit. When you can't solve for y easily, then you're going to have to do this skill in this process. And so here's implicit. You're going to differentiate both sides with respect to x, and then you're going to do some algebra. So let's do an example so you can see how this works. So let's look at this first one. When I look at this first guy, it says find dy dx for that long equation, and obviously I'm not going to solve for y. I can't solve for y very easily. So what you're going to do is you're going to go down the line taking the derivative with respect to x. So let me go down the line. If I take the derivative of 3x with respect to x, well, that's just 3. Plus, now what's the derivative of y squared with respect to x? Well, you take the derivative with respect to y, so you do the power rule, and you get 2y, but you have to remember dy dx. Now keep going down the line. Plus 4 dy dx equals, of course, the derivative of 7 is 0, so that goes away, and I have 2x. I'm not sure if you can hear my dog breathing. We just got back from a walk, so she's breathing heavy. Then, after what you're trying to do is you're trying to solve for dy dx, so I like to underline the things that have dy dx. You're going to keep those things, or move those things if you have to one side, and everything that doesn't have a dy dx, you're going to move to the other side. So I'm going to keep this 2y dy dx on the left. I'm going to keep the 4 dy dx on the left as well. And then the 2x I have, and I'm going to bring that 3 over. The whole point of me keeping the dy dx's on one side is now I can factor a dy dx out and have 2y plus 4 is equal to 2x minus 3. And then I can write my final answer. By dividing by 2y plus 4, I can get that dy dx is equal to 2x minus 3 over 2y plus 4. And notice the difference to an implicit is that when we did dy dx before, it only had x's in it. Well, now our dy dx, you could possibly have y's in your derivative as well. So the next part says evaluate dy dx at the point 2, 1. Well, let's look at the notation. Y'all, this notation is very, very important because remember, you can't just say, it's like you don't fill in like a parentheses. So I want you to see this notation. If I'm evaluating dy dx at a particular value, I say evaluate, so I put it there, and I put 2, 1, meaning I'm evaluating dy dx at 2, 1. So I'm going to put 2 in for my x, and I'm going to put 1 in for my y, and I'm going to get an answer of 1/6. Now, does that 1/6 tell me the same thing? Yes, it's the slope of the tangent line at the point 2, 1. And the reason why it's in, for these, how it affects x's and y's, these things aren't functions. It ended up being like a hyperbola, if you remember that from pre-cal, is that it ends up, and I'm not drawing this like any particular way, but a hyperbola looks like this. So 2, 1, you're looking and finding the slope of that tangent line. So you can see why it's kind of dependent on x and y because we don't have a function, so I need to know exactly which point you're talking about. So that's what implicit is. So why don't you try this next one? Or let me help you with this next one after that. Because this next one, you say, wait a minute. All right, so let's look at this next one. The derivative of x squared is 2x. Now as I go, this next one, I have negative x times y. Oh, dang, negative x times y, product? I have to do the product rule? Yeah, baby, you do. So I'm going to take negative x as my first and y as my second. So first times the derivative of the second plus the second. Do I write dy dx for that y? No, because I'm not taking the derivative. So just y times the derivative of the first would be -1 plus 2y dy dx equals, and believe it or not, this right-hand side is one of the most missed things. People put 7. You are taking the derivative, so make sure you put 0. Now let's do what we said. We're going to look at what has a dy dx, which is this one and this one. I'm going to keep him on the left and move everything that doesn't have dy dx to the right. And I'm okay with you combining some steps. So if I move that which doesn't have a dy dx to the right, I would have y minus 2x because I'd have to change their sign. And then when you look at what you have underlined, they both have a dy dx, so you can factor a dy dx out. I like to put my positive one first, so 2y minus x. And then I can divide to get my final answer. So dy dx is equal to y minus 2x over 2y minus x. And know this for multiple choice or looking at the answers that are on my page. You know, it really doesn't matter which side you move the dy dx's to and that which doesn't have. A lot of times I do left and right, but it doesn't matter. So if you see an answer choice where every sign is opposite, so if you had 2x minus y over x minus 2y, so notice every single sign, positive y, negative 2x, positive 2x, etc., those are equal. So I don't want you to get to a point where your answer doesn't look exactly what the multiple choice says or what the back of the, where your answers are, and you think that you did something wrong. If every sign is flipped, you have a correct answer, and that is your answer. All right, so why don't you try example 3, now that you kind of got the hang of it, and see if you can get down to a final answer. So stop the video and try that one. All right, here we go. Oh, product rule again. First, x squared times the derivative of the second plus the second times the derivative of the first plus 6y squared dy dx is equal to 3 plus 2 dy dx. Okay, well this one has lots of dy dx's. So I've got that one, and that one. So I'm going to take those to the left, and I'll move everything else to the right. So on the right, I would have 3 minus 2xy, because I'd move this guy over. And then on the left, I'd have dy dx. I would have an x squared. I would have a positive 6y squared. And if I moved that 2 over, he would be negative. And then I can get to my final answer. So I'd have dy dx is equal to 3 minus 2xy over x squared plus 6y squared minus 2. We getting the hang of it? So it's just a process. But gosh, then I think, yeah, I'm feeling good. And then I see example 4 and say, oh my gosh, I got to have trig in there? Yeah, let's put some trig in there. Let's make it a little more fun. Okay, let's do the trig. Remember the chain rule, okay? If I said, what's the derivative of cosine of 4x, you don't just say negative sine of 4x. You say negative sine of 4x times the inner derivative, okay, which is 4. So in the same way, if I'm doing the derivative of the cosine of y, it's going to be negative sine of y times the inner derivative, or in other words, times the derivative of y, so that would be dy dx, plus, well, that one's easy, 2x. Now let's look at this one on the right. The sine of x plus y. Well, it's going to be the cosine of x plus y times the inner derivative. Well, the inner derivative is the derivative of this argument. So the derivative of x is 1. The derivative of y is dy dx. Now, it's my suggestion, I'm like, okay, I see dy dx, but I have this multiplication, so I'm going to multiply this out. So on the left, I'm really not doing anything. But on the right, I'm distributing this, so I have cosine of x plus y times 1, so it's just cosine of x plus y, plus cosine of x plus y times dy dx. All right. Now, just to prove to you I can move everything to one side, a different side, I'm going to move those things that have dy dx. That one's positive. Since this one's negative anyway, I'm going to move it to the right, and I'm going to move the things that don't have dy dx to the left. So I'm going to, just to show you that you can, so I'm going to keep this 2x on the left, and then subtract cosine, didn't give myself enough space there, cosine of x plus y. So I'll take that to the left. And then on the right, I would have dy dx. This cosine of x plus y would be there. And then if I popped that sine of y, it would become positive. So I have plus sine of y. And then I just do my division. So I get dy dx is equal to 2x minus cosine of x plus y all over cosine of x plus y plus sine of y. So trig, you just have to remember the chain rule as you have done. And you have to remember product rule, and you have to remember all those things that we have put into place. You have to keep those in your mind. So that is implicit. So work on that. We're actually spending a couple days on implicit, so we'll be doing more implicit tomorrow. So work on this so you're not behind. All right? Peace out.